Hello everyone, my name is Francesco Cipollone, I'm the CEO and co-founder of Phoenix Security. This year we've seen an incredible acceleration in number of vulnerability. New agents have been spinning out and spitting out vulnerability at a pace that it was harder to keep up, and now is even more challenging. We never had a problem of discovery, even though discovery has become smarter with agents. We have a problem of a deluge of vulnerability that are coming towards our engineers. And with Phoenix, we've been always at the forefront of remediation with attribution, prioritization to focus on the right problem and delivering the right remediation to the right team to accelerate remediation. Now, this has worked wonderfully for us for several years, but this year we've seen the need to go beyond this, accelerate even more the remediation part, but also identifying the opportunity to close the tap and remove the vulnerability generation altogether, and reinventing scanning of vulnerability altogether to block and prevent vulnerability from entering the code base in the first instance. We have the chance with agent to teach machines to really code securely. And with Phoenix, we divided this in a 3-factor way: prevent vulnerability from being generated, block vulnerability at the source of generation, and burn down the backlog of existing vulnerability with agentic remediation. We call this the AI SDLC method, or protecting you from generation to remediation. But let's see how it works. So the idea is fundamentally breaking down the process, the agentic SDLC pipeline that we currently have, because humans don't write all of the code themselves, but focus on producing an idea and producing specification. For this particular control, we have Phoenix Purple, the agentic scaffolding control that writes for your specific project rules, guardrails, and protection to avoid the idea to be generated with security embedded, doing threat modeling and providing a secure specification so that the vulnerability don't get generated at architectural level. Now, with Phoenix, what we call now Phoenix Orange, that is the main prioritization platform where most of our clients have been able to reduce up to 98% of container vulnerability and up to 78% deduplicating SCA vulnerability with prioritization and attribution, getting to a single digit or to zero critical vulnerability. This platform has served us so well over the years. Today, we want to give them a superpower that is basically taking the backlog out of the existing vulnerability that you currently have at control number 9 and extrapolating the vulnerability that you're currently doing in your code base, on your container, on your ISC, on your secret, and writing scaffolding and blockers that can go behind your agent and blocking vulnerability from being reintroduced. We call this the superhighway for engineering, and the scaffolding that prevent them from making mistakes without them needing to think about the mistake they're making. So closing down the tap of vulnerability, as well as avoiding the vulnerability from being reintroduced and hence burning down the backlog. But we don't want to stop here. We want to go a step beyond. With Phoenix Purple, we look at the code and reachability analysis on steroids. We created a graph of knowledge that helps both security engineers to identify with a fraction of a cost, up to 33 times less, 0 days and vulnerabilities with frontier level identification of 0 days at a fraction of a cost on our cost of our minor model, because we help the code navigate. But the beauty of this is that engineers can use this method as well to help their coding agent getting faster and cheaper in terms of token burn. Our engineers use this technology both for identifying security vulnerability, but also identify and navigate the graph. So it's the first time a security tool can be sold to the CTO by saving the CTO money and producing security in the back. Phoenix Purple index all of your code base, keep the code base up to date, and analyze continuously your pull requests so that you have a live index of knowledge graph and security taint path that enable Phoenix Purple to deliver inside the agent session already the vulnerability once you finish coding with your agents. And the agent can take this context and fixing it, but at a fraction of a cost of what it will take you to develop a harness or send the vulnerability with a scale to a frontier model. We have a paper and an analysis that we're going to put forward to be transparent about the cost of scanning at scale, because prioritization and scanning will be the future of this. But again, we don't want to stop here. We want to protect all of the AI SDLC pipeline, and with malware coming at 4 to 10 times the rate that we were experiencing last year, we want to deliver inside the agent intelligence with Blue Shield and package malware security at the agent speed level, providing gating and blocking in case there is malware on the package that the agent has decided to use, but also providing a way for the agent to think and decide by himself what package is safe with the intelligence that Phoenix Blue and Blue Shield provide. At the same time, Blue Shield enabled you to invoke the human and block the execution of the agent. And we protect with Blue Shield both at agent level, at workstation level, and at CI/CD level, because the modern attack at different level and different layers of controls. And we protect your engineering machine that is becoming the front of your business at different level, from the agent perspective to workstation to CI/CD level. Same intelligence, same rules, apply at different level against your packages, malicious skills, and extensions that could compromise your machines and stealing credentials, like what happened with GitHub and Team PCP being rampant in this stage. And all of this technique we call close the tap, and preventing vulnerability from being generated and securing the highway for engineering to enable them to go fast to production in a safe environment where rules, skill, and guardrail protect them from generating malicious code, and spec and rules and skills prevent malicious consideration to be included inside the product specification. And then we have the real gate of the modern SDLC, that is the pull request in a CI/CD pipeline. At this stage, we insert the package manager, as I mentioned before, to prevent malicious packages from being promoted, because the speed between the developer generating the code and merging it to the main branch or to a branch could lead to a compromise, because packages are being exploited on a minute-by-minute basis. We process 40,000 to 100,000 packages per day, and we find thousands of malicious versions that are being produced across different ecosystems. So protecting the software supply chain at CI/CD level and a pull request level is super important. But with Purple, we wanted to bring the code scanning and the knowledge graph to the CI/CD pipeline, and providing a full contextual, reachable pull request analysis without the challenges that the pull request introduce. Traditionally, you have a pull request that introduces just a snippet of code, but you don't know if that code is malicious in the grand scheme of the compromise of the repository. With Purple indexing all of the codes from that particular pull request, we are able to identify malicious code being called from different parts and really bring the power of the graph at the speed of a pull request. Now, all of this will block malicious code from entering your pipeline, malicious container from entering your pipeline, and producing a safe environment. But we will still have an enormous amount of backlog that you need to prioritize. And you can build harness for prioritizing vulnerabilities, but it will burn an enormous amount of tokens. So with Phoenix Orange, we want to reduce the amount of vulnerabilities that are getting passed to our coding agent and our analyzing agents and vulnerability exploit verify, that is called Phoenix Green, that produce remediation with evidence of exploit in your particular code base and push those easy changes directly in the engineering lifecycle or directly in the patching backlog of engineers and analysts. In this way, you can fast track the easy changes and almost automate the easy changes and pay attention to the breaking changes or the ones that are important in your particular ecosystem. In this way, we want to protect the organization from generation of code and intelligence to remediation of the most important vulnerability in the backlog. At the same time, preventing vulnerability from re-entering the code base and providing a safe highway for engineers to produce code at the agent speed, but without the compromise of security. With Phoenix Security, we're defining the AI SDLC future by providing the superhighway of coding agent in a secure way with secure skills, guardrail, and analysis at a fraction of a cost of frontier model. This is Francesco Cipollone, and this is the future of security. Thank you.
Phoenix, fix vulnerabilities today before attackers exploit them tomorrow.